Hello students, today we are going to discuss about a sequence of real numbers, and at first we will see what is the definition says, and after that we will discuss about the definition, and also we will see an example of a sequence of real numbers. Okay, so let us see that what is a sequence of real number. What is the definition? So it says that a mapping if such that n to r is said to be a sequence in R or a real sequence. What it means? It means that a mapping if which is a mapping from n to R, that is from set of natural numbers to a set of real numbers. So the function which maps the element of natural number to the set of real number. Okay, this is the sequence. This is nothing but a mapping from the set of natural number to the set of real number. अगर ऐसा कोई भी सेट हो जहाँ पे सेट ऑफ नेचुरल नंबर सेट ऑफ रियल पे मैप हो रहा है तो वही एक सीक्वेंस होगा. And how did we denote this? So we can denote it as in curly braces or in triangular braces. Okay, and this we always take general term to denote a sequence like xn, f of n, or f suffix n. Okay, now let us see an example of a sequence. Let's say 2n is a sequence, right? Then what are the term? What are the elements of this sequence? So to expand this sequence or to find the element of this sequence, what we have to do? We just have to put the values of n. And what is n here? N is always belong to set of natural number because the domain of a sequence is always set of natural number. So in any example of a sequence, we basically have to put the set of natural number to expand the sequence. So let us see what it gives. So set of natural number, that is n, is 1 2 3 dot 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 to infinity. Now just plug in these values to the sequence. So this gives 2 times 1, 2 times 2, 2 times 3, and so on. So what we get from here? 2 times 1 is 2, 2 times 2 is 4, 6, and so on. So this is a very simple example of a sequence. Now let us take another example, which is minus 1 whole to the power n. And what is n here? N is belong to capital N, that is the set of natural number. Just plug in the values of n. So minus 1 whole to the power 1, minus 1 whole to the power 2, minus 1 whole to the power 3, and so on. So what it gives us? Minus 1, plus 1, minus 1, plus 1, and so on. Okay, so there is only two terms in this sequence. One is minus 1 and another is plus 1, and this type of sequence is called oscillatory sequence because in this sequence terms are in repeating mode. That is why this is called an oscillatory sequence, right? So this is an example, this is another example. Now we will see what is a limit of a sequence. Okay, so a limit of a sequence is nothing but a real number. Okay, so what is the definition of it? Let us see the definition. So what is the definition of a limit of a sequence? So let us define it first, and after that I will discuss about that. Okay, so let xn be a sequence, right? And what sequence? This is a sequence of real number or a real sequence. And small l be any real number. right? Then we can say L is the limit of the sequence xn if, now the actual condition, the actual properties start. So if, let us focus on this, if for any epsilon greater 0, as a mathematics student you already know that epsilon is a very small positive number. So if for any epsilon greater 0 there exists a natural number, okay, there always exists a natural number such that modulus of xn minus L, that is the difference of xn minus L is less than this small positive number, less than epsilon, for all n greater equal to k. Okay, so clearly see that what it says. Let xn be a sequence of real number or a real sequence and L be a real number, then L be any real number, okay. Then we say L is the limit of the sequence xn, okay. Then we say that this L is the limit of this sequence if for any epsilon greater than 0. What is epsilon? Epsilon is a very small positive number. For any epsilon greater than 0, there exists a k belongs to n. There exists a natural number, right? For any epsilon, there exists a natural number such that modulus of xn minus L, the difference, the positive difference of these two terms always less than epsilon, okay. Now, symbolically, we can write this. Symbolically, we can write this as limit n tends to infinity xn is equals to L. So this is the actual definition of limit of a sequence, okay. Limit n tends to infinity xn is equals to L, that is the limiting value of the sequence at infinity, at n tends to infinity, will be that point, and that point which is called limit of a sequence, okay. And remember one thing, that limit of a sequence is unique, okay. Limit of a sequence is unique.